Hello there. In this video we're going to prove the angle bisector theorem. The challenge in this one is that the triangles that you have in the beginning are not similar to each other. So the genius of it comes from creating another line. A line through point C parallel to AB. Then what we're going to do is we're going to extend BD out further, and it's going to intersect somewhere down here, and we can call that point P. I always like calling it point P. And that's going to do a couple things for us. So we're going to have that these angles in here are congruent to each other by the vertical angle theorem. And we also have some other angles because of the parallel line. So list that given. And we're going to actually have that this angle here, P, that is congruent to this angle up there. And that's true by the alternate interior angle theorem. Now the angle up here, well, that's actually the same as the angle over there, too. And this was given to me in the diagram, but we could have also said that BD is an angle bisector, therefore this angle is congruent to that angle. So we got that this one's up over here, and now we actually have a big triangle here, and that triangle is isosceles. Because the angle here, DBC, and this angle down here, P, are congruent. So it's isosceles because of congruent base angles. And what that's going to help us out with is that this length here, BC, that has to be congruent to that length there, CP. Okay, so how does that help us? We're going to have a small triangle on the lower right. So we'll list that one out. Triangle, I'll start at the blue P, go to the red DC, and that triangle is congruent to this one up here. So start at the blue, that's triangle B, go to the red, that's D, and then go out, that's A. And we know those triangles are similar. I'm sorry, they are not congruent to each other. They are similar to each other by angle-angle similarity theorem. Now I can write out all of those similarity statements. First over the first, second over the second, outer over the outer. Corresponding sides of similar triangles are proportional. And it turns out that I'm not going to need all of these. I don't need, I think it's PD and BD. I think those are the ones that turns out I don't need. But I can concentrate on the other ones. And there's a substitution that we can do here where we know that BC is congruent to CP. So this PC here, we can replace that with BC. And then through some multiplication and division, I can get BA to the other side, so BA over DA is going to equal BC over, get the DC down on the bottom, DC. So that was multiplication and division. And that's where we wanted to wind up with it all. So we effectively showed, and normally we'll do this with like simple letters. If the angle is being bisected, I like to call that A, B, C, and D. That side over here, A, that is the BA, so it's A over C is equal to the right-hand side, B over D. And there you go. All right, character and scholarship for life.